Hi, welcome back everybody. We are starting chapter 2 with section 2.1, increasing, decreasing, and piecewise functions. So, when we look at increasing and decreasing, we always want to go from left to right. And so for increasing, that means that we're going up from left to right. And for decreasing, we're going down from left to right. And then for constant, that means that we're staying the same, or it's going to be horizontal. And so we can look at this through our examples that we have. So for the parabola, we're increasing as we go from left to right here. But then at that point, it switches from increasing to decreasing. And so as we do this, we don't include our endpoints whenever we're writing our intervals, because at that point it is not increasing, decreasing, or constant, because it's changing at that point. So if we look at example 1, for our intervals on which the function is increasing, we just have one little section here, and so that is when x is from 3 to 5. Again, we're using parentheses because we do not include those endpoints, because that's where it is changing. And then for decreasing, we have two different sections. We have this section right here, and it is continuing that way, and then we have this other section over here. So it's going from negative infinity up to negative 1. And then again, because we're just listing our intervals, we do not have to use the union sign. We just separate our intervals with a comma. And then our other decreasing interval is from 5 to infinity. And then our constant interval is this little section that is horizontal, and that is from negative 1 to 3. And so for our relative maximum and minimum, this means that we're looking at our peaks for maximum or our valleys for our minimum. And so these formal definitions mean for the relative max, it's the highest point in an open interval. Whereas the relative minimum is the lowest point in an open interval. So if we look at this example here, we want to determine our relative maximum and minimum and the intervals on which the function is increasing and decreasing. So our relative maximum is this little peak right here. So the way that we write this is a relative max is 2.004 at x equals negative 0.082. And then our relative minimum is this little valley right here. And so we write that as a relative, I forgot my L's. So a relative minimum is negative 1.604 at x equals 4.082. And so then our interval for increasing, we can see that it's increasing as it's coming up, but then at that relative max it starts to decrease. So for our increasing, it's going going to go from negative infinity up to the x value at a relative max, which is negative 0.082. And then we also notice that it increases from our relative minimum and on. So then that would be from 4.082 to infinity. And then the section in between our relative max and min, it is decreasing. And so we put that it's decreasing from negative 0.082 to 4.082. And so we are going to skip examples 3 and 4. These word problems we will do in class. And so going on to piecewise functions. This means that we have a function that, depending on what x value we're looking at, it goes to a different function. So if we want to find f of negative 5, negative 5 falls under this interval. So since negative 5 is less than negative 2, we're going to plug negative 5 into our first equation. So we're going to do negative 5 plus 1, which is negative 4, and that is our answer. And so negative 3 also falls under this interval, so we're also going to do negative 3 plus 1, which gives us negative 2. But then 0 does not fall under the interval of being less than negative 2. It falls between negative 2 and 3. So for all of those x values, we're going to use that f of x equals 5. So no matter what x value between negative 2 and 3, and including negative 2 and 3, our f of x is going to be 5. So f of 0 is 5. And again, because f of 3, since it is included in this, then f of 3 is also 5. But now f of 4 falls in the interval that it's greater than 3. So we're going to use f of x equals x squared for f of 4. So we're going to take 4 squared, which gives us 16. And so again, 10 is greater than 3, so we're going to use x squared for this one as well, which means that f of 10 is 100. And so when it comes to graphing piecewise functions, we want to see what our function is at that sort of breaking point. So for example 6 with g of x, we want to see what our top equation is at x equals 3, and then also what our bottom equation is at x equals 3, and then graph from there. And so for example 6 with g of x, both of these are lines, and we know that once we have a point, we can then use our slope to determine the rest of the line. So let's see what our top equation gives us when we plug in 3. So we take 1/3 times 3 plus 3. So 1/3 times 3 is 1 plus 3, which is 4. And so we want to plot the point 3, 4. But since this is x is strictly less than 3, that means that we're going to have an open circle at the point 3, 4. We can also then graph this by going down 1 and to the left 3, or we also know that our y-intercept is at 3, and then we can draw this line. And so for our other one, we want to see what value we get for our bottom portion. So we take negative 3, which gives us negative 3. So this means that we have the point 3, negative 3. And so since it is included, since our x value is included in this, we're going to have a closed dot at 3, negative 3. And this has a slope of negative 1. I'm going to go down 1 and to the right 1, and then draw that line. Now, for this next one, we have 3 different functions as part of our piecewise function. So this top one, we know this is a horizontal line. Our middle equation would give us a parabola. And then the bottom one is a regular line with a slope. So we know that for a horizontal line, when x is less than or equal to 0, it's going to be 4. So I can draw that horizontal line. I'm going to have a dot at x equals 0. Now, for this middle section, because we have 2 different endpoints, we need to know what both of our endpoints are. So I'm going to plug 0 into my middle function. And so 4 minus 0 squared is 4. And so this is actually the same dot that we have from our horizontal line. And then I need to find my other endpoint, so I'm going to plug in 2. 4 minus 2 squared. So this is 4 minus 4, which gives me 0. And so with the dot, whenever we have this point 0, 4, because it was filled in from our horizontal line, that means that it's okay to connect it to this open circle. And then here, because the 2 is included, we're going to have a closed dot at the point 2, 0. And so we know that it is a parabola shape, so we can kind of curve it down a little bit. And so we need to find out what this endpoint is for our bottom. And now this one is not included, so I plug in 2 into my bottom portion. So 2 times 2 minus 6. So 4 minus 6 gives us 2. So this is the point negative 2. This is the point 2, negative 2. And again, this x value is not included, so we have an open circle at 2, negative 2. And then this has a slope of 2, so I can go up to over 1, and then draw my line from there. And then we will talk about example 8 in class. So, thanks for watching, and we will see you guys in class.